Hi friends, still with the Education channel. Before starting this series, this video is available for free. However, the process of making videos like this requires a lot of money. You can support this channel by following this channel, of course. What other questions will we discuss this time? This is one of the questions in the Physics Olympiad selection. Let's listen to this question with our minds for 10 seconds. To understand this question better, let's watch this animation. There is a block on the floor surface, and a thin homogeneous stick hanging from the ceiling. It looks like one end of the stick is connected to the axle, the other end is hanging freely. The block on the left side moves straight to the right at a constant speed. The block hits the end of the stick in front of it. Instantly the block stops moving, and the stick swings to the right until it reaches a certain angle of deviation. In this process we are asked to determine whether this collision is an elastic collision, or an inelastic collision. Furthermore, we are also asked to calculate the maximum height that the stick can reach. It is clear what is meant by the question. Let's start identifying the quantities. We don't know the mass of the block, right? Let's call it m. The speed of the block is v. It looks like the length of the stick is L. The mass of the stick is big M. Since the block stops immediately after the collision, we can assume that the mass of big M is much larger than the mass of M. Almost forgot, during the movement the surface of the block rubs against the surface of the floor. If we read the text of the question, we don't find any information there. If it is like this, we can assume that the surface of the floor is slippery. Mu is equal to 0. Thus, there is no dissipation of energy due to friction. Without friction, the velocity of the block before the collision is the same everywhere. Now, let's guess the important points. The points of interest. The first point is the point where the collision occurs. The second point is the point where the center of mass of the stick is at its highest point. It seems that all the important things have been identified well. Now let's analyze the collision at point 1. In the collision process, there are no external forces at all. We can say that in the collision, the law of conservation of angular momentum applies. This is similar to the block that can pull the pulley in the other video. The angular momentum of the system before the collision is equal to the angular momentum of the system after the collision. Since there are two objects, we can write L1 plus L2 equals L1 prime plus L2 prime. This L1 is the initial angular momentum of the block, mvl. Although the block has a size, we can think of it as a particle. The particle that strikes the free end of the stick. The distance of the free end from the axis of rotation is L. L2 is the initial angular momentum of the stick, I omega. Similarly, the angular momentum of L1 prime is mv prime L. And the angular momentum of L2 prime is I omega prime. Initially, the stick was not rotating, so omega is 0. After the collision, the block stops moving, so v prime is also 0. What is left is mvl equals I omega prime. This I is the moment of inertia of the stick. In the standard table, we know that the moment of inertia of a stick rotating about one end is 1/3 big ml squared. From here, omega prime is equal to 3 mv over big ml. The moving block has translational kinetic energy. This is the initial energy of the system. The rotating stick has rotational kinetic energy. This is the final energy of the system. We will check if there is any energy difference there. Let's just write, delta kinetic energy is equal to the initial kinetic energy minus the final kinetic energy. The initial kinetic energy is half mv squared. The final kinetic energy is half I omega prime squared. If you still remember, the value of the moment of inertia is 1/3 of big ml squared. We also know the value of omega prime. This calculation is quite easy. Delta kinetic energy is equal to half of mv squared, multiplied by 1 minus 3m per big ml. M and big M are positive. We can be sure that this value is definitely not equal to 0. It must be greater than 0, even though it is less than 1. So the value of delta kinetic energy is more than 0. In an elastic collision, the value of delta kinetic energy should be 0. Because the value of delta kinetic energy is more than 0, there must be energy loss there. A collision like this is an inelastic collision. In the next case, we will analyze the process that occurs in the stick. The stick rotates from a speed of omega prime until it stops rotating. The rotational kinetic energy at point 1 is converted into other energy. Let's look at the law of conservation of mechanical energy between point 1 and point 2. Before going any further, we must understand this: that the angular velocity of every point on the stick is the same. And the stick can be represented by its center of mass. So, we can shift point 1 to the center of mass of the stick, in the middle of the stick. The potential energy is measured with respect to a reference. We can choose point 1 as the reference point. The height of point 1 is 0 meters. Let's just write kinetic energy 1 plus potential energy 1 equals kinetic energy 2 plus potential energy 2. Kinetic energy 1 is the rotational kinetic energy at point 1, half I omega 1 prime squared. Potential energy 1 is the potential energy at point 1, big mgh1. Similarly, on the right-hand side we have half I omega 2 prime squared plus big mgh2. Omega 1 prime is the angular velocity at point 1, omega prime. The value of h1 is 0, because point 1 is the reference point. Omega 2 prime is 0, because at point 2 the stick stops spinning. The value of h2 is h. This is the vertical distance between point 1 and point 2. What remains is half I omega prime squared equals big mgh. We have found out the value of the moment of inertia of the thin stick. We also know the value of omega prime. A little scribble on the paper, and we get h equals 3m squared v squared over 2 big M squared g. This is the maximum height that the stick can reach. Hopefully useful. And don't forget to watch the next video.